is day 2 operations. For example, how to detect and handle security exposures. Important pieces, well, if there's a large landscape of deployed instances, how do we identify vulnerabilities and how do we efficiently trigger errata updates installation? Now, the nice benefit about using Cloud Forms is that we can actually analyze the disk contents of both running and non-running instances and templates, be they Linux or Windows images. We can then evaluate compliance with any pre-configured compliance rules that we want to develop based on, for example, the artifacts that are on the system, which packages are there, which applications are there, or also configuration entries. There's a completely integrated governance framework in Cloud Forms that allows us to invoke certain actions triggered by events. Governance rules, which are basically those triplets from actions, like, for example, new analysis results are available, conditions, like this is an unmanaged instance, and an action that is triggered from that. So, for example, the action for an unmanaged instance, if a compliance incident is identified, would be to send an email to the consumer that he should take action. It also allows, for example, reporting, so that we could view the state of the various different instances, compliance status from a report, so that an administrator can manage a large number of instances without receiving a large number of emails. And we've built up this scenario that way is that we enable the consumer not to have to do anything with the deep technical stuff, but he can really trigger the errata installation directly from the single pane of glass within Cloud Forms. So really the way that the scenario works is we have that cloud management platform in the middle that constantly triggers in the back end the smart state analysis, as we call it, analyzes the contents of the various different instances, apply the governance criteria, and if a compliance fault is found, sends out an email to the consumer for unmanaged instances who can then install updates, or we provide a report to the admin who manages a large scale of system. And for large scale management of a fleet of systems that is out there, Red Hat Satellite is the tool of choice where he can then trigger bulk updates of updates, bulk installation of erratas. So let's look into this. I'm logging in here, in this case as administrator. So the administrator doesn't have a full name, it's admin. And before I dive into that use case, just a couple of words on the user interface. Here you pretty much see the full user interface. You see all the different service entries, and you see that he has a reporting dashboard presented to him as his login screen. And that dashboard is actually configurable. So we could reconfigure it to move around. We can have here various different analysis views on the infrastructure that allows us to look at only specific pieces of that information. So this is really a highly configurable dashboard that addresses any question that an admin would have on his environment. So smart state analysis, the first thing we're going to look at is a very interesting concept because it works completely agentless. So smart state pretty much creates a snapshot of the underlying storage of the virtual machines and uses that snapshot to then analyze the disk contents and figure out what is actually on part of those virtual machines. And that is done completely without any agent running inside the instance. So we don't have to do additional steps to actually prepare the instances to run with our management framework. And there's no additional load within the instances to actually run an administration agent, but everything is done from the outside. So let me scroll down to the RHEL 7.1 cloud image. Here we've already run a smart state analysis, and you can see on the right hand side here the analysis results. We can, for example, see that in that cloud image, there are 25 different users configured in 43 different groups. We could see that there's 118 init processes and 333, nice round number, packages are installed on that in that image. And if we drill down, for example, in the packages, oops, let's go one back. I wanted to navigate to the OpenSSL package that we've identified before. You can see what we did using Secure Shell and basically looking at a package from within the instance. We can pretty much do that also through smart state analysis. So OpenSSL. Here we see the version number, we see some more details on that package that is installed. We actually even get a description of what that package does. So it's a very nice feature, and we get a similar level of information about the users, the groups, and if we were to configure that, we could also define which files the analysis should look for. By default, it does not look at all the different files that are in the virtual disk, because it would take a lot of time to analyze all the disk contents and to store them in the database. However, if we're looking for specific files, like there's an exploit in the wild and it usually leaves some traces in the form of files, we could even identify those files from within Smart State Analysis to use this as a criterion to then apply governance. By the way, we can do the same thing for Windows as well, so it is not limited just to Linux. We can also look at, for example, the Windows Cloud image that we use to instantiate the Windows virtual machine with. And here you can see the right-hand side looks a little bit different. We have 3 different users created. We have 15 different groups. You see the patches. You can see applications, Win32 services, kernel drivers, file system drivers, files, and registry entries. So we even have a parser for the registry and can look for specific registry entries once we configure a policy to actually look for them. So looking in the applications, what's installed in that Windows Cloud image from the outside. We can see there's Cloudbase init. That's the way to actually configure Windows images in an OpenStack compliant way. But there's also, for example, Internet Explorer installed. We can see who is the vendor, the version level, where is it installed, etc. So it's a number of information that we can then use to manage or to evaluate compliance with certain policies. So talking about those policies, let's navigate to those. I'm going to the tree of control policies, and there we've prepared a policy profile to check a specific OpenSSL version. And as you can see, the expression that is behind it is find a VM and look at the installed packages and check if a package named OpenSSL is there, check that the version is whatever, that is actually the version that we identified before that is running. And if that condition is actually true, then mark that instance as non-compliant. So it would be tagged as a non-compliant instance, and then another action could be to send a mail out to a user or to add it to a report so that the admin can add it. Now, unfortunately, there's a small bug in our instance, and we cannot show this running. However, just imagine that you were now sent as a consumer an email and you wanted to address this. You're being told that your specific instance is not compliant. How would you go about it? So I'm logging in as a consumer, and I'm looking at the services that I've requested so far. And by the way, the email that was just sent is probably that the Windows instance is now available as well. So we can anytime we want to, we can take a look at that. So I'm looking at the managed instance that I've ordered, and that's CFME 231. Here I'm now being told it's an unmanaged instance. Cloud consumer, you are responsible to actually install updates, install fixes. However, I'm too scared to actually use a command line and interact with the system directly. So here we've provided a nice round button which says install all updates. And that allows me as a non-technical consumer to actually do this task. And again, we send out this request, and that basically triggers the systems management tool in the backend to now install all the available updates on that specific system. Seamlessly, without the user having to learn about specific Linux technologies and how to install, for example, fixes in Linux versus fixes on Windows. Probably doesn't have to even care about how to do it in Windows as well. Unfortunately for this demo, the actual installation of those fixes, we were talking about 30 to 40 fixes that are available for that system that are now being installed. It will take a couple of minutes. So I would like to revisit that specific instance later and see if something has changed. And I would now go to the managed environment. And for managed systems, we would assume that once the administrator gets a report that, for example, 1,000 images need updates because there was an exploit in the wild and a certain OpenSSL version is actually affected from it, he would not want to do it system by system by clicking a specific button here. So he needs a specialized tool for systems management, which is Red Hat Satellite. So I'm logging out as a consumer in Cloud Forms, and I'm logging in to Red Hat Satellite as an administrator. And here we're taken to the Red Hat Satellite user interface, and that is really a specialized tool to manage large scale system environments. I just want to show a specific functionality. We've configured a number of host collections. And what you see here is that there are two host collections. One of them is all the different managed RHEL 7 system, and one of them is all the unmanaged RHEL 7 systems. And as an administrator, I would consider myself to be responsible for the managed RHEL 7 systems. So I'm moving here. And here there's a number of actions I can actually take on that collection. And one of them could, for example, be errata installation. So I do want to install a number of fixes on a number of systems. Now, unfortunately, in this demo scenario, at the moment, there's only 2 of them available at the moment in that collection. So I'm now looking to make this a little bit faster, OpenSSL. And I can see there are, let's see how many errata are available. Yeah, 2 bug fixes and 3 security errata on OpenSSL. So I would suggest to install those 5 on those 2 systems. I hit install all selected, yes, and I could do the same thing for example, 1,000 images that are running. Okay, so this probably takes a while. One of them was already successful. I assume that the Cloud Init test instance already had those errata applied. However, the CFME 232 still needs updating, so this will take a little bit longer. And once the errata installation is completed, we can actually log into the system and see if the OpenSSL version changed. You can even view more details on what is currently going on. This is a technical console. You can see which steps are running. If any errors occurred, you could even restart the installation if errors appear along the way, and we can drill down to see the Dynflow console, which is the actual engine that is running in order to perform the various different tasks. Okay, moving back to that UI, I can see that 100% is completed. The Errata installation is through. So I do want to log in now into the system itself. That was, sorry, I have to check again which one it was. Host collection. It was a managed instance. Content hosts. Okay, it's CFME 232. I'm logged in here in CFME 231. So I'm logging in again as into CFME 232. Okay, and if I now check the OpenSSL version, rpm-q OpenSSL, I can see that there's a fix now installed. It has same version number, but it has a subversion number EL7_1.9. If we compare it to the node we took before, it's this one down here, you can see the version number differs. This component is now new. The fix has actually been installed. And where we can now also check is that the same thing also already take place for the unmanaged instance, where the actual consumer triggered the installation update. Let's search for that instance that we have. It's CFME 231. And here we can see which tasks were running. And you can see there's a large number of Errata to be installed and is at this moment still running. So we don't see the updates yet, but it will take place in due course, and we might be able to look at it in a later point in time. So that was the use case on how to identify security vulnerabilities and how to manage Errata. So let's move on to the next use case.